Welcome to LNP Renewable System Integrator. Today we are going to discuss some of the basics of HVAC, heat, ventilation and air conditioning systems. So in the basics, we will be finding the solution for the following questions. That is, what are the comfort requirements, and what are the 5 system loops in a heat, ventilation, air conditioning system, what is air side loop consist of, and what are the cooling load components in the HVAC, what is the supply fan in the AHU of a HVAC, how it looks like and how it works, what is chill water cooling coil and how it looks like and how it works, what is VAV, that is variable air volume, how it looks like and how it works, what is FCU, fan coil unit, what is constant air handler in the HVAC, what is the supply air distribution system, how a supply air distribution system looks like, and how a chill water loops works, and how a evaporator, pump and the control valve, small chill water systems, refrigeration loops, compressors, condensers, and what are the different types of condensers and expansion valve, how all these components are going to work, we are going to see today, and how heat rejection loop works, and what are the water chiller and the cooling coil, cooling tower works, how control loop works, and how a DX unit works, and what are the different system categories, how it works, and most importantly how to analyze a project, and most importantly how to make a cost effective project, what are the important parameters that we need to consider before choosing the equipments. So in our discussions we might be using so many symbols and short forms, so if you have any sort of doubt, kindly refer to the this part of this video so that it will be easy for you. Because we might be using so many symbols inside it, and also we might be using so many acronyms and short forms of the mechanical equipments. So if any sort of doubts when you're listening to the video, kindly please refer to this part so that it will be easy for you. So what is the acronym and the expansion of the short forms that we have used, and also in our discussions we might be using so many terminologies, say for example air cooled condensers, building automation system, compressors, condensers, cooling towers, diffusers, direct expansion unit, brain pan, evaporator. So when you have any sort of doubt, when listening to the video, you can refer to the glossary part so that you will get a clarity about the equipments that we are going to discuss. So first and foremost thing is that what are the comfort requirements? When can you say a particular location is very comfortable for you? First thing is that the temperature. The temperature should be good one. The temperature should be a good one. It means it should be a very nice temperature so that you can sit there. Second, for most important thing is that the humidity. Humidity should also be a good one. If it is too high, you will felt suffocation inside that particular room, so that you feel very difficult to live in that concerned room. When you go to the sea areas, near to that locations, there is a possibility for high humidity in the concerned rooms. And also air movement should be there. If there is a room, there should be a sufficient supply air, and also the exhaust air going provision should be there. There should be air movement, and most importantly the air that we are receiving should be a fresh air. That is the most fresh and a clean air. So if you need a fresh air, you need to create your environment with the beautiful surroundings, and most importantly for a cleaner air you need to have a natural cleanser, and also you need to use many sort of filters for filtering methods for filtering the air, and also there should not be much pollutions and noises also. And also lighting should be comfortable one, and the furniture and the work surfaces that you have should be a good one. So the which is going to decide the comfortness? Temperature, humidity, air movement, fresh air, clean air, noise level, lighting, and furniture and the work surfaces are going to decide your comfort. Next, in HVAC, that is heat, ventilation and air conditioning system, 5 important loops are there. First is the air side loop, second one is the heat rejection loop, third one is the chill water loop, and fourth most important thing is the control loop, and fifth most important thing is the refrigeration loop. Means it is like a closed loop. Means there will be some entrance, okay, there will be some input and there will be some process is going to happen. You will have an output, okay, but even though your output is perfect, but still, you will take the feedback, okay, you will take the feedback of your concerned output and you will compare them, you will process them, then you will produce the required output. So this process, this closed loop process will be happening in all the loops, even from the air loop, heat rejection loop, chill water loop, control loop and refrigeration loop. Means if you are having a supply side of air, then for sure you will have also a return side in the air. In the same way, if you have something to supply for the heat rejection, then for the return side, for the rejection, for removal, you will have any process. And most importantly for the chilled water systems also, okay, in order to supply the chilled water, you will have a supply pipeline and also you will have a return pipeline also. And most importantly, okay, next in the refrigeration side also, say for example, if you apart from water, we can use so many refrigerants to cool or for heat transfer, okay, for heat transfer or heat exchange process, we can use the refrigerants. So it means if you are using any sort of refrigerants, okay, using that, if you are taking away the heat from the concerned room, okay, you are taking away the heat from the concerned room, again you can reutilize the refrigerant. So for that you are going to undergo an important process of refrigeration loop. And also the control requirements is very much important. Inside the control requirements, using the what are the things that you will be controlling? You will be controlling the temperature, you will controlling the humidity, okay, you will be controlling the pressure, okay, you will be controlling the damper actuators, okay, you will be controlling the chill water actuators. So it means for the HVAC to work properly, all these loops should be perfect, should work. So if a system is good, if you want to establish a comfortness inside a concerned building, you need to establish all these 5 loops. Next, first if you get into the air loop side, as I told earlier, as you can see here, this is a room, okay, inside room, as you can see here, we have a supply air. So even though if you are supplying the comfortable and a clean air, in order to exhaust the unwanted residual air, you need a return side, so you are taking the return air through the other duct. So it means we have a supply duct as well as we have a return duct. And second most important thing is that since this is a conditioned room, okay, for sure there will be a possibility for sensible heat inside it, and also we will have a moisture content inside it. So it is our duty, using the HVAC equipments, we need to condition this space, okay. So if we consider what are the cooling load components, as you can see, okay, say for example, first and foremost thing, we as a humans, people are the first most important load. Next we will have a light, okay, because light can produce some sort of heat. So if heat is there in the confined room, that is with the help of that light we can able to change the temperature of the air which is present inside it. So it is also going to be a load. Second thing, there will be some equipments, okay. If you are having a PC, okay, if you have a exhaust fan inside it, it will be exhausting some hot air outside. So it is our duty, it is also being considered as a load, it is going to affect the temperature. So it is our duty to maintain that temperature, cool down those equipments also. And most importantly, we have some glass doors, okay, with the help, if the sunlight is entering inside, it also will act as a load for it, okay. And also if you have exterior walls are going to be a load, and if you have a floor, the floor is also going to be a load. So it means when you decide, when you had a plan to calculate the load for the HVAC, you need to consider all these things, okay. So next most important thing is the supply fan and the filter. So as you can see here, okay, in order to supply air to the conditioned space or a room, okay, first thing we need to do, we need air. So where the air is available, air will be available in the outside. So outside air is very much important. Second thing is that we can take the air directly, because even though it is a fresh air, we need to filter it. So for that filtering purpose, we are using the filters. Then even though if we design that properly, okay, it doesn't means that the air has to go to the concerned location or concerned space properly. So we need to direct it. For that we need the supply fan. So this supply fan is playing a very important role on the air side loop, which delivers the supply air to the space. Next is the cooling coil. So as we told earlier, okay, even though we are getting a fresh air from the outside, using the filters we are filtering it, okay, so it doesn't mean that the outside air should be cool always or it should be heat always. Okay, so in order to reduce the temperature, we need some exchanger, heat exchanger. So for that one we are using this cooling coil. So cooling coil will act as a heat exchanger. So and most importantly, it should be cold enough to absorb the heat which is present inside the concerned room. So for that purpose, as mentioned earlier, so with the help of the supply fan we will be supplying to the concerned room, but we will be supplying a cold air. Okay, if this air come in contact with the cooling coil, a heat exchange process is happening, so that the temperature of the concerned air is getting reduced, and the air that we are going to supply through the supply air will be cold one. So using that cold, we can absorb the excess amount of heat which is present inside the conditioned space. And as I told earlier, okay, if you are using the chill water cooling coil, okay, as you can see here, and the one side will be the warm humid air, on the other side it will be a cool dry air. Okay, and even sometimes during this conversion process there will be some losses, so we will be having a drain pan also. We can collect those draining water drops using the condensate drain line. Next most important thing is that constant volume system. So what is this constant volume system? It is a system which provides a constant quantity of supply air and varies the supply air temperature in response to the changing cooling demand. So as you can see here, so if you want to achieve some temperature in the concerned room, in order to achieve the temperature, some sort of modification, some sort of changes, some sort of process we need to undergo. So those process where it will be, so as you can see here we have a cooling coil, so there will be a supply line in the return line. In the return line we will be having a cooling coil. We will be having a chill water actuator. Using this chill water actuator, we will be controlling the water flow. We will be controlling the water flow. So by controlling the water flow, we can change the temperature of the air which is coming from the outside through the filters. It is when it is passed through, come in contact with the cooling coil. So because of this process, with the help of the chill water, by controlling the chill water actuator flow, valve flow, we can able to change the temperature, so that with the help of the supply air we will be supplying to the conditioned space. Next most important thing is that a variable air volume unit, okay, VAV system. As you can see here, even though we might be using the air handling units for big spaces, meeting rooms, okay, it doesn't mean that the AHU will have only dampers alone, the supply side alone, supply fan alone. Apart from it, on the field side, okay, on the field side, on the room side, we will be having a VAV, that is variable terminal volume unit. So the main duty of this variable terminal volume unit is that it varies the quantity of constant temperature, especially the supply air, in response to the changing cooling load in the space. So based on the temperature, okay, we will be, this is going to be the damper. So damper actuator. So using this damper actuator, we will be controlling the airflow. This is the damper. So we will be controlling. It will be operated at different positions, so that if you want to maintain 100% flow, so it will be open fully. If it is 50% open, so you can send only the 50% of air to pass through it. So next and foremost thing is that fan coil unit. So as you can see in the fan coil unit, we will be having a filter, we will be having a supply fan, we will be having a return air inlet, and most importantly we will have a cooling coil. In the cooling coil, okay, on the supply, on the return side, we will be having a we'll be having the chill water actuator to control valve, especially opening and closing of it. Why we are doing it? To maintain and establish cooling, and establish cooling for the air which is supplied to the concerned room. Next is the central air handler. As you can see here in the central air handler, we are having a supply fan, we are having a filters for filtering it. So this is the outside air which is coming inside to it. So with the help of the supply fan through the filters, we are supplying the air to the concerned room. And as you can see here, with the help of the cooling coil, so we can able to cool down the air which is being present in the supply fan, and so that with the help of supply air outlet, you can supply the air to the concerned room. So as I told earlier, when you get into the supply distribution system, see here, this is a central air handler. This is the outside air inlet. Through this only the air is coming inside it. As you can see here, inside the central air handler, we have a supply fan, we have a cooling coil. So with the help of those things, we are able to cool down the temperature of the air which is passing through it, so that we are getting a cool air, and we are trying to supply that cool air to the concerned room with the help of this diffusers and most importantly the VAV terminals. And as you can see here, apart from the supply duct, we are also having a separate return duct, and through the return duct, this is the inlet of the return duct. So this return duct, in order to supply the return air to the external environment, we might be using the exhaust fans also. Next most important thing is that a chill water loop. So in the air side loop, a cooling coil is used to cool and dehumidify the supply air. So this process is called chill water loop. As you can see in the chill water side, so we will be having a supply side, and we also having a return side. For cooling, we can mostly, for most of the application, we might be using water. But for if you are using any sort of refrigerants, if you are planning to do the refrigeration cooling, you can use any sort of refrigerants apart from water. These are the cold fluids which might be flowing through the tubes of the coil. Next and foremost important thing is that the evaporator. As we told earlier, apart from the cooling coil, if you want to reduce the temperature further, you can go seek the help of the another important heat exchanger, that is the evaporator. So its main duty is to cool down, make the water flowing through the cooling coil much more colder than the air passing through it. So as you can see here, we have a chill water supply inlet, and we also having a chill water return inlet. As you can see here, we have so many tubes inside it. Next is the pump and the control valve. So what is the role of this pump? What the pump is going to do? So if you want to move the water from one location to another location or through around the loop, you need the help of this pump. So since we have a cooling coil, so if you want to move the air from one location to the other location, you need the help of the fan. The same way, if you want to move the water around the concerned loop, you need the help of this pump. And most importantly, in order to control the flow of water or a refrigerant or coolant in cooling coil, we need the help of the control valve. So in control valve, we have two different types. One is two-way control valve, and the other one is the three-way control valve. So as you can see in the two-way control valve, it simply reduces the rate of chill water flow through the coil. As you can see in the written line, it is reducing the rate of flow. So when we open it, more water will flow. If you want to establish the temperature, you need to close it down. You need to retain the water and you need to leave the water very slowly, so that the air which is passing through it this cooling coil will become much cooler. When you get into the three-way control valve, as you can see here, it has three different works. One is you will have a supply line, you will have a return line, and apart from it, so the quantity of water flowing through the system, okay, flowing through the coil plus water bypass is constant at all loads. So in a three-way valve, the water flowing will be constant. Okay. Next, this is a simple example of a small chill water system. As you can see here, these are the chillers. Okay, and with the help of the pump, we are making a circulation inside a concerned loop, cooling loop. So as you can see here, with the help of the pump only, we are pumping the water into the chiller, and also we are taking the water from the chiller to the cooling coil and through the control valve, and again we are reprocessing and sending it back to the chillers. So as you can see here, the most important loop which is happening here is the refrigeration loop. As you can see here, if you want to cool down the air or the water which is passing through it, or the refrigerant which is passing through it, we need the most important person called this evaporator. Okay, it is going to play important role in the refrigeration. And most importantly, as we told earlier, okay, if we need, okay, in a HVAC system, if we want to do any heating purpose or cooling purpose, okay, apart from cooling coil, pump and evaporator, we need a help of other important person called compressor. So it is used to pump the low pressure refrigerant vapor from the evaporator and compresses it to high pressure. So what is happening, as you can see here, the temperature of the liquid which is entering the compressor is only 10 degree, but after compression it is getting changed to 48.9. again if you send back it to the evaporator, it is getting cooled down. So this is like a cyclic loop, it is happening continuously. Next is the condenser. Okay, so after being discharged by the compressor, okay, from the compressor, we need a condenser. So what the condenser is doing, okay, when the vapor enters the condenser, okay, the condenser is act as a heat exchanger. It transfers the heat from the hot refrigerant vapor. Okay, so there will be refrigerant vapor will be passing through it. It will be transferring the heat from the hot refrigerant vapor to the air which is present inside it. Or if you want to do use water also we can use, or some other liquid also we can use also. So what is happening, as you can see here, the temperature when entering here is 48.9 degree. When it cross through the condenser, it is getting reduced. So what are the three different types of condensers? So we have three different types of condenser. One is the air cooled type, and the other one is the evaporative type, and the third one is the water cooled type. So in the air cooled type, as you can see here, we have a propeller fan. So only with the help of air we are going to cool down. We don't have any refrigeration vapors. Okay, and also we have a fine tube coil. We also have the outdoor air. But when we get into the evaporative cooling type, in the condenser, as you can see here, so we will be, with the help of the pump, we will be taking the water from here, from the sump, and we will be spraying it. So because of the spraying process itself, first and foremost thing is that the heat is getting reduced, and also with the help of the propeller fan, we are taking away the air from here to the external environment, so that the water is getting cooled down. As you can see here, when we get into the water cooled type, as you can see here, when water entering, it will have a high temperature. When it is exit, the temperature is getting reduced. Next, what is the use of this expansion valve? So as you can see here, in the entire loop, along with the evaporator, compressor and the condenser, we are having an expansion loop. So what is this expansion loop it is doing? So in the recycling refrigeration cycle, hot liquid refrigerant passes through the expansion valve. It creates a pressure drop. So when suddenly the hot liquid is passing through it, it creates the pressure drop. Because of it, okay, the correspondingly the temperature is getting reduced. As you can see here, after crossing through the condenser, the temperature is 43.3 degrees Celsius, but when it undergoes a sudden expansion, the temperature is getting reduced to 3.3. If we didn't use any sort of chill water line inside it, using the air cooled condensers also we can establish the cooling. So when we look into the fully packed rooftop air conditioners, as you can see, most importantly we will have a supply fan, okay, and in order to cool down the air, we are using the cooling coils. These are the air cooled condensers, and we also having the compressors, and most importantly to take away the exhaust air, we are using the exhaust fans. So how a heat rejection loop is happening? As you can see here, we have 4 different color codes. So here the fourth important loop is the heat rejection loop, okay. So in the refrigeration loop, the condenser transfers the heat from the hot refrigerant to the air. So inside the condenser, what is happening? Heat transformation is happening from the refrigerant to the external environment, okay. So in a water cooled condenser, water flows through the tube while the hot refrigerant vapor enters the shell surrounding the tubes. So as we told earlier, inside the cooling tower, okay, what is happening? So we are taking away the water and we are spraying it here. In the parallelly, what we are going to do, with the help of the propeller fan, we are taking away the heat which is present inside this, so that the water which is getting dropped here will be a water with a less temperature. Next, as you can see here, okay, for the cooling coil also we are using the pump, okay, and even for a heat rejection loop also we need a support of the pump. So as you can see, when a water chiller and cooling tower, if you are using it, so we can have a water cooled condenser there, and this is the cooling tower, and with the help of the pump we can pump the water which from the cooling tower to the water cooled condensers. If required, with the help of the 3-way control valve, we can control the flow either to the water cooled condenser or we can bypass the pipe. Again, we can send back to the cooling tower. So, and most important thing, if you get into the packed air cooled cooled chillers, so we have 3 important loops. Okay, one is the normal supply fan air loop. The second most important thing is the chill water loop, and third most important loop is the air cooled condensers. So how a controlling operation is happening? So as you can see here, with the help of the building automation system, BAS or BMS, most importantly we might be using the DDC controllers, or we can use either PLCs, programmable logic controllers, or application specific controllers. Okay, so it can be of any brand, either we can use Siemens, Schneider, Honeywell, okay, Johnson Control, like that. Any sort of brands is available in the market. The most important loop is this control loop. So this control loop will be interfacing with all the other loops. Okay, it will be controlling the fan, okay, it will be controlling the evaporator, it will be controlling the valve, okay, it will be controlling the valve in the heat exchanger side, and also it will be controlling the expansion valves. Like this, the system level controllers plays a very important role, and with the help of the building automation system, the entire functionality, the entire control loop is getting controlled, so that whatever temperature required will be achieved in air side as well as in the water side also, and whatever the unwanted heat, air or water, it will be removed. So as you can see here, this is a rooftop variable air volume system. This is a packed rooftop air conditioner, and with the help of a duct we might be supplying with the help of the VAV terminals we might be supplying the individual rooms. As you can see here, apart from the air handlers, variable air volume units, we can use with the help chiller network will be going through with the help of a pump. It will be going, the supply line will be going to IAHUs, that is fan coil units, okay, and return air line, return chill water line will be coming from the air handling units as well as the fan coil units also. So next most important component is the DX unit, that is direct expansion unit. So from the word itself we can easily came to clarity that okay, direct expansion is happening. Okay, so what will be doing, it is referring to the position of the evaporator with reference to the air side loop. Okay, so when the fine-tuned cooling coil, okay, in the direct expansion system, the fine-tuned, this is the fine-tuned cooling coil of air side, is also called as evaporation. It comes in direct contact with the air side, air stream. Okay, when liquid refrigerant passes through the expansion valve just before entering the cooling coil, okay, the temperature is getting reduced, a major temperature change is happening. So as we told earlier, if we do the air cooled DX system with the help of the air cooled condenser, this is the operation which will be happening inside it. So when we are going for a normal chill water loop, so all these things should be there. And if you want to have a remote evaporators also, you can design if you have any sort of requirement, that is split chill water system. And what are the factors which are affecting the decision? First and foremost thing is that the installation cost you need to consider, energy consumption, space requirement, okay, building height, system capacity, stability and control, and individual tenant buildings. And if you are planning to install, okay, the cost is all very much important. So when you see, if you plan to install for a smaller project, scalable project, you can go with the air cooled DX unit. But if it is a project is very big, if the capacity is very big, in such occasion it is better to go with the air cooled chill water system. So as you can see here, okay, for the DX unit no need pumps, but for the chill water system to work properly you need help of the pump. Apart from it, in both we have supplying the exhaust fan and also condensers or a cooling towers. So whenever you are making a space requirement for the roof type, you need to know the total area it is going to cover, or if you are planning to install the equipment inside the indoor, that is equipment room, you need the space details also. So as we told earlier, so when the packed water chillers are more, in such occasions instead of going for DX equipments, it is better to go with the chillers. And what are the system requirements? So we can categorize the air volume delivered by the supply fan with respect to the different sort of zones of the supply fan. Single zone constant volume, single zone variable volume, multi-zone constant volume, and multiple zone variable volume. So as you can see here in the single zone constant volume, okay, the outside air is entering, and with the help of the supply fan we are trying to supply the air to the zone or a room, okay, zone or a room. On what basis? Using what as a reference we used to control the flow of the air, in constant flow, volume flow of the air inside the concerned room with the help of this thermostat, that is the temperature sense. Its main duty is to measure the temperature inside the concerned room, okay, and you need to convert that physical quantity to either 4 to 20 milliamps electrical quantity or 0 to 10 volt DC output, okay. So what in the single zone constant volume type, we also have another example, that is packed terminal air conditioners, okay. So as you can see, these are the front grill and these are the filters, okay. We have a condenser and the supply fan inside it, and we also having the compressor and the air cooled condensers inside it. As you can see here in the packed DX rooftop system, we have a different deck, okay. We have a VAVs on different floors, and with the help of diffusers we are supplying the air to the concerned rooms. Next is the chill water terminal systems, okay. We can use classroom unit ventilators also in order to establish the cooling inside it. So in the single zone constant volume, either you can use 4 pipe or you can use 2 pipe system. If you are going for a 4 pipe system, coils per terminal unit should be 2. If it is a 2 pipe system, it should be 1. Okay, and water distribution piping is 2 in the 4 pipe system, whereas in case of single pipe it will be 1 set. Okay, and most importantly, in the 4 pipe system and also in the 2 pipe system, we will be doing a temperature control directly. And for heating and cooling purpose, in the 4 pipe system, either or both simultaneously we will be using, and for the 2 pipe side, mutually exclusive. Okay, and if you are planning for a humidity control in 4 pipe, you can do it directly, but in case of 2 pipe, you need to either do indirectly only. So these are the simple examples of the outdoor dedicated outdoor system. Okay, in the outdoor duct, if it is directly into the spaces, okay, maybe some sort of air get reduced, but after processing only we are sending it out, unless and until if it is a waste, then only we will send, otherwise we can reuse it. Next most important application is that water source heat pump system. So the main advantage of this heat pump system is that if you want to establish the cooling inside a concerned room, you can do it with the help of this heat pump system, or if you want to establish the heating during the warmer times also with the help of this single heat pump system, we can do it. Next most important thing, for heating purpose, we can also use the geothermal heat exchangers, which is already available underground. Okay. Next is the single zone variable air volume unit. As you can see here, we have outdoor, we have a supply fan, and with the help of the supply air, we will be supplying the air to the concerned zone or the area. Next, multiple zone constant volume. In the multiple zone constant volume, as you can see here, we have outdoor air and we are filtering it with the help of cooling coil. We are cooling down the temperature of the outdoor air, and with the help of the supply fan, we are trying to supply it to the different locations, different zones in the concerned room. So what is happening here, the multi-zone concept is getting added. As you can see here, with the help of the reheating coils also, we can reheat if there is any sort of requirements to do. Okay. So this is a simple example of a multi-zone air handler. As you can see, the supply duct is getting inside this room, and also it is also going to some other room. It means in the multi-zone, it is very much important on the return air side, and also the water which is air which is going to the external environment is the external air, outside air. Changeover bypass switch. When we will be using this changeover bypass? Most importantly, if there occurs any sort of maintenance, okay, maintenance purpose or any sort of emergency purpose, we might be using the changeover bypass system. Say for example, let's consider a railway station. Okay, so you have a concourse level and you have a platform level. Okay, what is happening? We have a separate, dedicated EHU for the air handling unit or for the platform level. Consider a situation, it got faulty. Now without this air handling, you can supply the required supply air to the concerned project. So what will be happening? Instead of that, what we can do is that the concourse level, if the EHU which is running, okay, already supplying the one side of this area perfectly. If we have any sort of bypass ducts and the dampers, we can open the bypass damper, so that what will be happening, the temperature will be controlled here also. So as we told earlier, we have a changeover bypass systems. Okay, and most importantly, how we can do with the help of this multi-zone variable volume. As you can see here, the outside air is getting inside, and with the help of a cooling coil, okay, it is getting cooled down, and with the help of the supply air, you might be supplying to the individual rooms. So these are the variable air volume units. If you want to do only cooling, you can go with this type, or if you want to do parallel fan powered also, you can go with this type. If you want to do cooling with the reheat option for the VAVs, you can go with the type, or if you want to do the serial powered using the variable air volume terminals, you can use this model. So next most important thing is that DX rooftop VAV system. As you can see, the packaged DX rooftop air conditioners These VAV terminals will act as a diffusers. These are the things which is going to happen inside a system level controllers. As you can see here, if you are planned to use a self-contained DX VAV system, as you can see here, we have a cooling tower, we have a VAV, and also we will have a diffuser to supply inside the concerned room. Okay. Next, chill water VAV system. As you can see here, apart from the air, we also have the central chill water systems, so we can able to supply based on the demand. 2-fan dual fan VAV system. So the external air is getting through it, okay, and it is passing through the this dual duct VAV terminal. As you can see here in the words, we can able to see we have a dual ducts inside it. So most importantly, if you are trying to construct a building or making any sort of HVAC support, the most important preference that you need to give is the business owner. Second will be the developer. Okay, and most importantly, the available cost construction budget will be considered when you plan any sort of this HVAC equipment installation. Most importantly, we need to look into the interior, mechanical, electrical, others. Okay, all these things you need to consider. And if you are going to the function of the building, as we told earlier, we have a comfort requirement of temperature, humidity, air movements, fresh air, clean air, and the noise level. So thank you so much. If you have any sort of doubts, you can contact us. We have provided the contact details here. We as Electric and Automation, we are providing PLC programming training for Siemens, Allen Bradley and Delta PLC, and most importantly, if you want to be industrial specific, okay, we will be helping using the short-term courses of this building automation, building management system, and if you have a plan to establish the solar DC light systems, we can able to support. And most importantly, you might have an agriculture farms. If you want to protect your crops from the wild elements, instead of going for normal fencing, you can use the solar electrical fences. And also, if you had an access control system, okay, if you are planning to control the concerned rooms with the help of a card, it is better to hold it for a long time so that it will be easy to get inside it. Okay, so it means there are so many tips that you can learn when you do course with us. Okay, so thank you so much.